So in this class, we will study about the universal law of gravitation. So the definition is like this. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. So there are three things in this definition. We will understand all the three. Every object in the universe attracts every other object. So whatever may be the object. Object means what? It will have some mass and shape. So mass is important here. So every object is having some mass. Between two objects there will be always attractive force. Not repulsive, always attractive. So the force which is proportional to the product of their masses. So directly proportional means if the mass increases, the force will be more, attractive force. If mass is very less, it will be less. And inversely proportional to the square of the distance between them. Distance also matters. If it is inversely proportional here, that means if the objects are nearby, the attractive force is more. If it is far apart, then it will be less. So this I represented with a diagram. So we will, first I will write the diagram. Objects A and B, two objects we have selected. Then their masses, one is capital M and the other one is small m. Okay. Then force, always attractive. Okay. That is, I'll call it as F. And distance between them, say D. So these are the parameters. See, object A, object B, and mass M, small mass m, and the force is attractive. This attracts this, that is this. This attracts this, same force, F and F. And the distance between these two is D. Okay, now as per the according to the universal law of gravitation, so this force is proportional to the mass, product of the mass. That is, see, force which is proportional to the product of their masses. So here it is m into m. This I will call it as equation 1. And the second one is force is inversely proportional to the square of the distance between them. Inversely proportional is like this, 1 over the then square of the distance between them, these two. So F is proportional to product of the mass of both objects and inversely proportional to the square of the distance between them, as per the universal law of gravitation statement that is converted into mathematical formula. Now we will combine these two equations. Combine equations 1 and 2. Then F is proportional to m into m by d square. Okay. Now proportionality constant, we will remove it. Then we have to put a constant. So we will call that a constant as G, m into m by d square. Okay. So where the G is the constant of proportionality. Constant of proportionality. And it is called Universal law of gravity, universal law of gravitation. Universal gravitation constant. So it is a constant. So we will call it as universal gravitation constant. That is G. G is universal gravitation constant. So we want to know the value and the units of it. Okay. So for that, actually the value is given. Anyway, we are not going to do any derivation. This is with experiments they will find a value. G 6.673 into 10 to the power of minus 11 is a value, and it has to have a units, correct? So it is Newton meter square kg to the power of minus 2. Okay, this is the value of universal gravitation constant. So how these units have come, that we will see here. So using this, I will call it as equation 3. From equation 3, that is F is equal to G m into m by d square. So I will cross multiply this. So F into d square become G m into m. Here also 1 into, correct? F into d square is equal to G into m into m. Further, what we want is G. So G is equal to Fd square F d square by this capital M into small m. So G in terms of all these values. Now we will write here again G is equal to F d square m into m. So let us write the units of it. Force is in newtons, distance is in meter square, and this is mass is in kgs, kg into kg. That is Newton meter square by kg square. So that is nothing but Newton meter square kg to the power of minus 2 when you take this up. So this is the unit of universal gravitation constant, and this is the value of universal gravitation constant. Whichever equation, whichever numerical you take, this value remains same. That's why we will call it as constant. Okay? Yeah. So here from the textbook, this is from the textbook. See, the value of G was found out by Henry Cavendish in 1730. This person was living in between 1731 and 1810 by using a sensitive balance. So using some sensitive balance experiment, he has found this value. The accepted value of G is 6.673 into 10 to the power of minus 11 Newton meter square kg minus 2. Okay. Further, we know that there exists a force of attraction between any two objects. Compute the value of their force between you and your friend sitting close by. Conclude how do you not experience this force. If you sit nearby with your friend, you are not getting attracted, okay, but you are not even feeling the force. So that I want to solve like a numerical. Okay. So let us take two students. Okay. Let us take two students of weight 40 and 45 kg. Okay. Now we will calculate the force between these two students. So the formula is F is equal to Z into M by D square. Here let us take capital M is 40 kgs, small m is 45 kgs. Okay, now substitute distance, I will take it as 1 meter for easy calculation. G is equal to 6.673 into 10 to the power of minus 11 Newton meter square kg to the power of minus 2. Okay, now we will substitute these values. F is equal to 6.673 to 10 to the power of minus 11 into capital M 40, small m 45 divided by D square, 1 square. Okay, it is nothing but 1 is 1 only. So this you need not do the calculation. This is, I already done the calculation. So this 6.673 into 40 into 45 into 10 to the power of minus 11. These three numbers will give you a value of 12011.4 into 10 to the power of minus 11. This is very difficult to understand, so scientific way we will write. That is what I will do. 4 I will multiply with, I want to make it 1 point something, so that is a scientific way of representing. 1 2 3 4 4 zeros I have to shift, so multiply by 10,000 divided by 10,000 in 10 to the power of minus 11. So now if I this 011.4 divided by 10,000, whereas here this is minus 11 plus 4 zeros. Okay, so this will become 1.20114, so I will ignore these things. It will become 1.2. okay, I'll round it out to 1.2 into 10 to the power of minus 7. Okay, how many? This is in newtons. See, the attractive between you and your friend is 1.2 into 10 to the power of minus 7. That means that many zeros below this means very, very it is not even 1 Newton. It is very, very less. Very small value. That's why you are not seeing it. And if you are sitting 1 meter apart, if you sit much more distance, it will be much lesser. Okay. If masses are big, then it will become bigger. Okay, the attractive force will become bigger. So we will take this example given in the book. Example 10.1. The mass of Earth is 6 into 10 to the power of 24 kgs, and that of the moon is 7.4 into 10 to the power of 22 kgs. Okay. If the distance between the Earth and the moon is 3.84 into 10 to the power of 8 kilometers. Okay. Calculate the force exerted by the Earth on the moon. Okay, with all these values, it is all calculated. We are interested only in the final value. So the force is 2.01 into 10 to the power of plus 20. So what we have seen is minus. In the case of students, we have seen minus 7. Here it is plus 20. So it is a very good force. That's why because of this force only, Earth is able to hold the moon always with it. Okay. And something more. So this is no more. The law is universal in the sense that it is applicable to all bodies. That's why we will call Universal Law of Gravitation. Whether the bodies are big or small, whether they are celestial or terrestrial. Celestial means outside the Earth. Terrestrial means what is there on the Earth. Inverse square law. This you just understand. Say that F is inversely proportional to the square of t means, for example, that if d gets bigger by a factor of 6, F becomes 1 by 36 times smaller. Correct? No. F is proportional to 1 by 36. 1 by 1 by d square. That is 1 by 6 square. 1 by 36. That means what? F becomes 36 times smaller. Okay. So this is the meaning of inverse square law. We will also go through this section 10.1.2, that is importance of the universal law of gravitation. 4 points are given. We will quickly see these points. First one is the force that binds us to the earth. See, this universal law of gravitation is applicable for all sizes. So like for example, my weight maybe around is 80 kgs, but earth weight you have seen very huge, but still earth is attracting me. Not only me, everybody, everything on the earth. So the force that binds us to the earth is because of gravitation. The second one is the motion of the moon around the earth. So that's just now we discussed. The earth is not going away from, the moon is not going away from earth because of the gravitational force of earth on moon, and similarly moon on earth also. The third one, the motion of planets around the sun. Similar to this, even all planets are going around the sun because of the gravitational attraction of sun as well as the planets. The fourth one is the tides due to the moon and the sun. This is something new for us. So why it happens? Take earth. Earth is covered by ocean. More than 70% is water only. So let us take sun is this side, moon is this side. It happens. That time what happens to the water? Because this is all getting attracted. So water, instead of evenly distributed around the earth, okay, it will slightly bulge. Means this water is trying to go towards the moon. This side water is trying to go towards the sun. Okay, because of the attractive force. So because of that only there are tides. In some areas of the coast in the world, sea level comes up and goes depending upon this. This is one way. Sometimes sun as well as moon will be on one side of the earth. In that case, water which is evenly distributed around the earth. This side no moon, so most of the water will come to this side because both are getting attracted by the sun and moon combination of this. Okay, here this attractive force will become more because of these two are on one side. So this is the reason for the tides. Okay, high tide, low tide, it is all because of this. See, for example, here high tide, this side it will become, because all this water would have come this side. See, this level slightly would have fallen. Okay, this is low tide and this is high tide. Okay, okay.